Hello, everyone. My name is Yelena. I'm a faculty in data analytics program. The purpose of tonight's session is to introduce you to R and RStudio, which is what you're going to use in your Data 630 course. All right. So here is tonight's agenda. We're going to talk about what is R and what is RStudio. We're going to talk about environment and an interface. We'll talk about how to save your work. We're going to talk about using variables. We're going to talk about reading data from CSV file into the data frame. And we're going to talk about how to analyze the data, such as applying filters and basic data visualizations. All right. Okay. So let's get started. This is a screenshot of data that we are going to use for today's demonstration. We're going to use the human resource data. This is a source. And the data is tracking the employee job satisfaction level, when the last employee, number of years since last evaluation, how many projects the person was on, how much time the person spent with the company, and whether the person left work or still works there, right? Department and etc. Salary. So this is just a screenshot of data that you will see later tonight. Right? So what is R and what are its advantages? R is a language for statistical computing, right? It's free and open source. So basically you don't pay anything, right? It's just available for different operating systems. So whether you have Mac or you have Windows, you can download it. Excellent data visualization and advanced statistical methods. You may save commands in a file, and I'll show you how, because you want to make sure that the work is reproducible and you can share it with others. There is excellent documentation, and R is continuously evolving. As we speak, somebody develops new parts, all right? And it can be used with databases. There is more than one way to produce the same result. And R is also supports parallel processing, right? But of course, can we solve all problems as R? No. Well, R itself does not have a graphical user interface. You need to, it takes some learning curve. You need to know how to read help pages. It's case sensitive. It might not solve all problems that you're trying to solve, and performance is slower than Python or Java, right? Then you cannot embed it into application because it lacks basic security. So those are some drawbacks, right? So what do you need to do? How do you start? You need to install the latest R version, right? Then you need to install the RStudio version. Very important, R can be run, in general, can be run without RStudio, but RStudio cannot be run without R. But you need to install both, and I explain why. So as you know, R does not have a nice, it doesn't have interface, right? RStudio, it has some interface, not much, but some, right? So you're gonna install the latest RStudio version and the latest R version, R first and then RStudio, all right? Most of you probably already installed. So what is RStudio? It's an integrated environment. It makes things a little bit simpler. You may run your code, and it has a nice syntax editor with highlights. Then you can preview the different functions and etc., different outputs. And important, you may not use RStudio without R, but R can be used without RStudio, right? And you might see the commands history. This is really nice, isn't it? Now, R scripts, what you're gonna do in this course to make sure that your work is reproducible, you're gonna save all work into the R file, and I'll show you. Here is the RStudio interface. It has 3 panels. This is what you'll see, right, when you download it. Here, in this panel, console panel, you see the R version when you first load, right? See that's a version and the date when the version was released. That's the latest that I have in here, right? That's the latest. Console window is also the window where you may run the commands in here. Like for example, if I want to check what version of R I'm running, right? I can type the command here. But the problem is the chain of commands that are right here, who knows, it's not going to be reproducible. It's hard to reproduce, right? I would have going with up and down arrows through the command history. right? It's very difficult. Then how am I going to share my work with instructor if this is an assignment and I'm asked to turn in the code? What I'm going to do, right? So what you'll need to do is this. See this? You're going to go File, New File, and you're going to do R script, right? And the file extension is .r. Like in Microsoft Word, you have its files, and PowerPoint, you have files, and here the file extension will be .r, right? So this is untitled. That's where you're gonna put your code, right? And then you're just gonna save it. You're gonna go File, and you're gonna go Save As, and save it to the folder where you want to save it to, right? By default, the name is untitled, but you're gonna rename it. Let me close this for a while, and I'm not gonna save, but first I'm gonna talk about the windows that you have. So console, you know that you can run commands in here. When you run the command from the file, which you'll see tonight, the commands will be echoed here. The output will show in the console window. All the warnings and errors will appear here also, right? Our next thing here, this is an environment. At the moment, it's empty because I have not done anything, right? I have not created any objects yet. All right, empty. History is a history of commands. Well, you may see something here. I was playing around with something. So this is what I ran, right? Don't worry about connections. Tutorial, this is something optional. Maybe if you want to learn it more, there is a package that you can download and etc. It's optional. Now here, this is the files, and it shows the files in the current working directory. Current working directory is a folder where R is going to look by default, right? There's by default, if I want to list all files, this is the folder that it's going to look at. That's what's a working directory. And I'll show you how to change it tonight. Plots, this is where all your visualizations are going to be at. Packages. Package is a set of functions and documentations grouped together. That's what it is, right? Some packages are pre-installed. They come when an install R, and some packages in this course you will need to install. For example, our rules package is the first package that you would be installing, right? So that's packages. Help. R has rich help system. You can search on any topic, right? And I'll show you how to run the command to display help page. And this is really nice because see that it tells you in which package the function is defined. Like for example, this is a bar plot page and package name is graphics, right? Everything is organized in packages here. Okay, now what we're gonna do, what I did for you is this. I prepared already the code that we're gonna look at tonight. This is a little shortcut. If you don't remember where you saved your file, but you know that the files that you recently had opened. See this recent files, and this is my introduction to R file. This is a file, you're gonna have it after this session. I'm gonna let you have a copy of this file, all right? So now let's go back to the slides. So I showed you what an R script is. It's a code that you're gonna write the code file. Most of you are probably familiar with the code files from other classes, right? That's a file. And for your assignments, I believe you need to submit a copy of the code too. Okay, so next one. Well, to run the R script, and I'll show you how. Like for example, see this. This is the code, right? So here, this hash thing, this is a comment. Comment describes what the code does, but it's not actually executable code. But this here, this is executable. See this? To run one line of code, I'm going to put my cursor on that line and I'm going to click on run. See this? I clicked on run and it's going to run command. It's going to show me here the output, right? So there are multiple ways to produce the same result, right? See this r.version and version going to produce the same result. For session info, it's going to give me different information. For example, those are the packages that are already in memory, right? So statistics, graphics, all of these are the libraries that are already available to use, all right? And other stuff, your operating system version, etc. System time is going to show me the current time. ls at the moment, ls will return nothing because it shows what you're in your environment right now. And I have not done anything. And objects will return nothing. Now, data. What data returns is that it returns the set of pre-installed data set. For your first exercise, ungraded exercise, you're using iris data. What is iris data? Where is it coming from? There is a package in R called data sets, and not data, iris data that you're going to use, and you might see some questions on it in future quizzes. It's installed, it comes in the iris data, but in the dataset package. Data command will return you the list of pre-installed data sets. So let's see what you have. I'm going to run this data command, and those are the data sets that are available. This is a package called data sets, and this is what is in there, and iris is one of them. All right. So that's what it is, right? So you basically, this is how you run the commands. And this is, it's just simple. You can use your R as a calculator. 5 plus 9. What is this? Take a look at this. Everything in R is a vector. Here, the first element of a vector starts with a 1, right? So this is a 1 element, right? The starting position is 1, just only 1 row, and I'll show you when we have more. Starting with position 1. It's an output, but output is a vector also. Right now, see, my environment is still empty. Why? Because I did the calculation, but I didn't assign the result to anything, right? So what do I do? What else you could do? This was just put welcome to data mining, right? Again, vector, output is a vector. Now what I'll do, this is different. This is an assignment operator. I'm going to create X, and I'm going to assign it 3 to an X, right? There we go. And then here, X, it's just going to show the output what X is, right? It's going to show the output what X is. But there is a shortcut. There is a shortcut. What this does is here, it assigns value 5 to Y, and it's going to also print the result. It's going to also print what Y is. So you may nest the commands. So this will just show what Y is. See this? I assign the 5 and show what it is. RM command, the purpose of RM command is to remove objects from the environment. Suppose that I have something big, right? Suppose that as something big, and I no longer need it. I want to free up some memory. So I'm going to run the RM command, and X is the object name, right? Variable name. So I'm just going to click on RM. X is gone, right? But if I want to remove everything, well, look at this ls command. Ls command, it lists all objects in the memory, right? So here I'm taking this is the parameter. RM may take the whole list, right? So I'm passing the whole list to RM, and it will remove everything that I have in the memory. Alternatively, I could use this broom here icon. This broom icon, and I can use to remove everything from memory. Options, right? It's just going to show you options. Like, for example, if the warning message is too long, I want to see the first 1000 characters, and etc. Right? Those are the options. Now you might be wondering how to clear the screen. This is how to clear the screen programmatically, right? It clears the console window rather. All right, dev off. Right now it won't work because I don't have any plots. It clears the plots. History. This will show the commands history. Note here, right now I'm in environment tab. I'm gonna run, and it takes me to the history tab. The last 5 commands are visible. That's what I want, right? Now I mentioned everything in R is a vector. You can create vector. You use combine command, right? So C is a combine command. What it's gonna do is it's gonna combine numbers 1 through 5 into a vector, right? So I'm expecting to get a vector. But again, my environment is going to be empty because I'm not assigning it to anything. I'm just outputting the results. And see this, why does it say 1? It's because the first element of this vector is at position 1. This is not the number of elements. This is the first position, so this is 1. It will make more sense when we have a longer vectors, right? When we have a longer one that spans across 2 lines, you'll see. Now, I can do this shortcut, right? I can do instead of listing numbers 1 through 5, I can put 1 column 5. And here I'm going to do a little bit different. I'm going to assign it to an X, right? And I'm going to print what an X is. Very important, R is case sensitive. If I was going to put lowercase x, I'm going to get an error. Not found because my X is case sensitive, right? Now, suppose that I have 1,000 elements and I only want to see the third one. So you specify the index of an element that you want to see, right? So far we are so good, but those little things are going to add up into bigger things. Class is going to show the data type. Class of X, X is an integer. Type of is going to show the same thing, right? It's going to show the same, that it's an integer. Well, the reason I give you multiple ways to produce the same result is that depending on which book you read, you might see it done differently, all right? str is going to show you the structure. This is the structure, right? You've got 5 elements and those are the values. Now, suppose that I want to have something like numbers 1 through 5. I want to skip 6 and 7, but I want to do 8 through 10. You can do it like this, 1 through 5, comma, 8 through 10. You can do it this way too, right? Now, I can also do, suppose that this is my y, right? And if I want to output the element of y at position 1 through 6, I can do that too here, right? So then I check what the data type is going to be integer, right? This is a structure. Then what's going to happen if I multiply this by 2? It's going to multiply every element of y by 2. And here I check, I verify that the command did what was intended, right? But look at the slides first. So, I went over each window here. I wrote down what each window does for you. And I talked about that, right? I talked about this thing, but I just spelled it out for you. So also another thing is that you have 2 views of the environment. I'll show you. See this? Those are X and Y. Other view is to do the grid. One reason sometimes you want to do the grid if you want to see the size. If you want to see the size, and also if you want to remove one of your objects non-programmatically, you can just select it here and click on a broom, right? It will clear the object in the workspace, this selected object. If I don't select it, will clear everything. But I can toggle between list and grid view if I want to. All right. Now we talked about that. This is just an explanation of the vectors, right? Okay, so next thing is the sequences. I want to do the sequence of 10 elements starting at 1. So basically, usually you would specify the number of elements. You want to specify the start, right, and increment by. But if you specify just one number here, right, it means that I want to do 10 elements. But if I did not specify where to start from, it's going to start from 1, and it's going to go increment by 1. So this is my z, and I output it here. So that's what it does, right? Here, I want to start from 2. I can specify that I want to start from 2, then I'm not going to see a 1, right? This one, I want to start from 2, right? But I want to increment by 2. You see this? I want to start at 2, stop at 10, and increment. Oops, okay, let's print M. Here it is. So I want to stop by 10, at 10, sorry. So this is where I want to stop, right? 10. It starts with 1. That's what it's going to produce. The element starts with 1. Because I specify where I want to stop. If I don't say where I want to start, it will start at 1. And if I don't say increment, it's going to do by 1. But I changed it by 2, okay? Now, next thing, I mentioned that R has excellent help. How do you do help? How do you get help? Very easy. You put question mark and you put the command name. That's it. When I put question and the command name, it's going to show me the help page here. See, this is the page on the bar plot. It's going to give me the command usage. and it's gonna give me some examples, see? So the command can take optional parameters. I can specify the plot title, right? If I was gonna do this, I can specify the x-axis, what my y-axis is. I can specify the borders, the colors, etc., right? So here, this is just some explanations for each parameter that you can use. And there are some examples in here. See this, you can run some of these examples and they use the pre-installed data. Okay, they define on pre-installed data. Alternatively, you can spell the whole word, right, bar plot. But what happens if I don't know how to spell my command? I know it contains bar, but I don't know exactly how to spell. What you can do is you can type apropos. Apropos is going to return the list of commands that contain bar. See this? So then I'm going to say, this is what I want, okay? And then I put question mark and this command that I want. Now, take a look at this. Right now, our output does not fit in one line. This here, it shows the position of the first element on the current line. So this is position 1, this is position 4, position 7, right? Position 10, that's what this number does. All right? Then you can run through examples. If you put examples, bar plot, you can run through examples, right? And this one will search online help manuals. This will display the online help manuals for the bar plot, right? So I'll let you play with this. Now what we're gonna do? Well, for the first exercise, you were lucky because the data was pre-installed. But are you going to work only with pre-installed data? No, right? You need to be able to read the data from your desktop, right? And the files that I showed you the preview of earlier today, this is the files that we're going to read from the desktop. The data is about employee HR, and we're going to do some analysis of that. So in the first command, what we need to do is we need to set the working directory. Working directory is a folder where R is going to look by default, right? And set WD is a command that sets working directory. Trust me, on my C drive, I have a folder that I call data sets, right? Very, very important, case sensitive here, folder name. I have this folder on my C drive, and that's where I saved my file, right? So you're gonna have a copy of the code, you're gonna have a copy of the file. If you want to watch this presentation and follow along, you would need to either create datasets folder on your C drive or change this location here where you save the file, right? So this will set the working directory. Let me run this command. How do I know what's my current working directory? This simple, you run get WD command, it will return what's your working directory. Alternatively, if you look at the title bar of the console window, it shows that the working directory, right? So it's here. All right, now what you can do, this one list files, it's going to show me what files are in working directory. For example, suppose that I don't remember how I spelled my file name. So here is going to give me the list of files that I have. Now, I'm not sure if this file exists. For some reason, I tried to read the file and I'm having problems. So first of all, let's check if the file exists, right? It's going to return true if I have the file with this name. True, then it exists, right? Next step, we want to read this now, right? We want to read the data into something called the data frame. Data frame is an object into which we read the data from the CSV file, right? So if we go, this is about the help file. That's command history. I showed you that. Working directory, right? So that's where you set. You telling R where to look for the file. You can do it for duration of the session, right? Just by running this command, or you can also do it in a general settings. Okay, you can also do it in a general settings to change it. All right. Now, how do you read the file? So there are several parameters here. First of all, you have to specify what file you want to read. you want to set the header to true. It means that the first row in a file is what? The headings. You want to pick up the column headings from the first row in the data file. It's a comma delimited file. As is equals false. Well, you have some columns where the values are the character values. You do not want this to be read as a string, right? So that's why it says as is false, right? So now I'm gonna show you now. I'm gonna read the file here. Okay, I need to go to R. I like to show here more. So basically, this is a file name. Header equals true. It means that my column headings are already in the file. I don't want it to call column 1, column 2. I want to use my headers, right? So let's read this. All right. So what did it do is it created something called the data frame. This here shows the number of rows and the number of columns. We need to make sure that the number of rows matches the number of rows in a file. Well, of course, you want to add 1 because the first row in a file is the column headers, right? And in here, this is just number of data rows. And here, it means that you have 10 columns, right? Well, you can expand this, you can see the column names, their data types, etc. But remember that usually R does not have an interface. I need to know how to see, how to preview data and how to view the data structure programmatically, right? So suppose that I want to see my data in a data frame in a spreadsheet view. How do I do it? I'm going to run the view command, right? I'm going to run a view command and it's going to open the spreadsheet view. And I can sort the columns if I want to, etc. See, I sorted it by satisfaction level, etc. I can play around with this, but let me close this. Now, how am I going to display the first 6 rows? Head command is going to show you the top rows. But if you don't specify how many rows, you're going to see the first 6 rows in the console, right? So head command is going to show 6 rows, not 5, not 3, but 6. If I want to have 10, I have to specify that I want to have 10, right? Well, and of course, this is wraps because the number of, see, it cannot fit on the same line, right? All columns cannot fit on the same line. That's why it wraps here. All right. So now head shows the rows in the beginning, right? This is going to show in the end. Tail it shows in the end, and similarly, last 6, or you have to specify how many. Okay. Now we're going to talk about the properties. Data structure properties. What is it? HR is what? Data frame, right? Data structure. Well, if I'm lucky, if I have this window, I can see my structure here, column names, etc. But again, I need to be able to do this programmatically. How do I do it? I'm going to run the str command, and it's going to give me this information here. See this factor, data types of factor, accounting, HR, etc. Right, so here, levels, those are the valid values, the possible values that this column can have, right? So for example, salary, in this specific case, I have high, low, medium. I don't have the specific number. I have high, low, medium in here, all right? So, and these columns are integer. And here it just basically shows what does 8 mean. Well, I have 10 values of the account of the department, 10 departments. 8 means that the value in the first row is 8th department from that list. That's how you read this, right? That basically just shows how to read this. Like, for example, here, number 2, it means that the value in the first row is low, right? The second one on that list. Here, the value in the second row, it's going to be medium, right? It's a third one from this list. That's what it means, okay? Now, this one is going to show the data types, and this is how you check. See, this is a data frame, and this is how you check if it's a data frame. Well, it might sound easy, but sometimes in the code, you need to check. You might have something like, if this is a data frame, do this. If this is not a data frame, do that, right? So you have to know how to check the data type. Now, Names is going to list the column names, right? Alternatively, you can do is call names. Remember, see this? Here, the output is several rows. This is the position of an element. That's what it is, okay? A call names is another way to display the column names. See, the same. Dimensions, dim is a number of observations and a number of columns. I see this information where, if I look here, this is the information, right? But again, I need to know how to show it programmatically. I'm just going to run this dim command, right? Maybe because sometimes I want to do something like, I want to write a code where I'm pulling the number of rows programmatically, and I want to iterate through each row, right? So this. Now remember, what is this? This is a list with two elements. First element is the number of rows. Second element is the number of columns, right? So HR is a data frame. What if I'm interested only in the number of rows? I can show an row command, right? Or I can take only the first element in the output of dim command, of dim command, right? That will do the two. Number of columns, I can do, there are 4 ways to do that. I can do encall command, right? I can do lens command. I can take the second element from the output of dim command, or I can take the lens. What is names HR? Names HR are what? The column names, right? Those are the column names, and length of the column names is going to give me the number of columns, right? Important thing to remember is this. str command shows the structure, right? Like column names and data type. Summary command is going to show what? The statistics, right? It depends on the column type, the information that it shows. Descriptive statistics. So HR is a data frame. Let's run the summary. Let's see what's going to happen in here. Let me expand this window a little bit. This. So let's take a look at this. What is this here? Well, I'm gonna see this one. I see a lot of columns, right? I see the columns in here, and for each column, I'm seeing some information. What information? Satisfaction level is a numeric column. I'm seeing the 5-number theory, right? 5-number summary, sorry. Minimum, first quartile, median, mean, third quartile, and max, right? I see this. It's 6 numbers. Here, last evaluation, that's when the person was last evaluation was. But see, the thing is, what is this, an ace? It means that one of the rows is missing a value for this column. That's what it means. We get to missing values. But what this means is that I have one row that does not have last evaluation value, okay? So now let's take a look at this here. This is, what is this? In here, departments. See this? There are multiple departments, at least 10 at least. So what it does is it's going to list the department name and the number of people who work in the department, right? So this is department names and the number of people who work in the department. But what this does is this, it's going to show me only the first 6 dominant departments. The first 6 dominant departments display here, and category other is everything else other than these 6. It's not going to show, by default, it's not going to show all departments. It's only going to show 6 dominant, right? But we can fix it. Okay, I'll show you what we can do. But see this one, you don't see other because there are only 3 values for the salary. But, well, see here, this is a max sum. You can change it. This will show 9 departments, right? I specify the max sum parameter that will show me the 9 dominant departments. Instead, it should supposed to show 9 instead of 6, right? 1, 2, 3, 4, 5, 6, 7, 8. Oh, this is total. Other is the 9s, okay? So if I specify 9, it's going to list up 8, and it's going to group the rest into the last category, right? So I specify how many I want to see. Now, there is a different way to see this, to run the summary command. It's this. Oh, well, wait a minute, I'll get to it. But first, take a look at this. Suppose that my data set has 200 columns, and I only want to see the summary data for satisfaction level. This is what I do. I put my data frame name I put a dollar sign, and after the dollar sign, you specify what the column name, right? You run this, and it's going to show you just the statistics for one column, okay? Now, this is another way to run the summary command. lapply will run the specify command on every column in the specified data frame. So lapply, I pass the data frame name, and I pass the command that I want to run. So instead of running one command like this for each column, right? I can use lapply command and apply the summary command to each column, right? This is what it's gonna do, but take a look at the difference here. Here, it does not limit me to the 6th department. It's gonna show me all departments and how many employees work in each department. This is just the difference at output, it's the difference at how it shows, right? So if I scroll up, it's just gonna show me. I still see this NA. It means that here I have one row in here, one row that missing a value in this column, and we'll talk about that. Now, there's too much information, right? But what if I want to know only minimum satisfaction level? I can run the minimum function, right? Then if I want to know minimum and maximum, I can run the range. Another thing that you may have noticed is this, it does not show the standard deviation. How do you get the standard deviation? You run SD command. It's going to show the standard deviation. It does not show. Now, suppose that I want to know what unique values were. I just run the unique on the department command. It's going to give me departments. Alternatively, I can just run levels, because levels are values of the factor column, right? And here I can just do the aggregation. I can list the maximum. I can list the maximum satisfaction level by department. That's what it's going to do. Maximum satisfaction in this case is 1. Now, here, this is a subset. Sometimes I need to take the subset of rows and subset of columns. So the format in general is this. You specify the rows that you want to take, right? And then the columns that you want to take. Here, I want to take the first 5 rows, 1 through 5. Here, the list of columns is omitted. It means that it's going to give me all columns, see? If I want all columns and I'm lazy to spell their name, I can just put comma and leave this blank. It's a shortcut. It's going to give me all columns, right? Now, I can also create a new data frame, and I can assign the first 5 rows and all columns from this data frame. New HR is going to be another data frame, right? It's in here. See this? I can do this. It has 5 rows, right? 5 rows that I did in 10 columns. Now, what I could do also, I could take, well, this what will do, it will take first 5 rows and the first 3 columns. I'm specifying that by position, right? But here, I could also do, this will show the first 6 columns, right? This will show the first 6 columns. But names are just the list of column names. It's just one way to do that, right? It's a list of column names. Now, suppose that I want to show, so here I showed 3 consecutive columns. What I want to show the columns at the position 1, 4, and 5. How do I specify the positions? I'm going to specify it as a list. To do that, I use combine command, and I specify the columns that I want to take, and I want only first 5 rows, right? So that's what I do. Now here, suppose that I don't know the column position, but I know the column names. Sure, I use combine command and I specify the column names that I want. But in this example, the rows are omitted. I didn't specify which rows I want. What this will do is it's going to show me these 2 columns and no rows, right? Next thing is that I have a lot of data in here, but I only want to know the salary in the first 4 rows. This is how you do it. You put the data frame name, $, followed by the column name. And here you just specify the rows that you want to see. Easy, right? So far, so good. So far, we're good, right? Oops. Why does it say object 8 is not found? Because I highlighted A and R thought that I want to run A. I want to output A. That's what it thought. So you don't highlight it. You just put the cursor and run, right? Now here, well, this is specified, you can specify the condition. You can select rows that meet the certain condition. Like for example, in here, I want to list all rows, right, where salary is medium. The columns are omitted. It means I'm going to show all columns from the data set where salary is medium. That's what I'm doing. I can also combine my conditions. Suppose that I want medium salary and I want department to be HR. So this is an AND operator. There are OR operators and there are AND operator. It will return the row if both conditions are true. That's what AND does, right? So here, this is HR and the medium. I no longer see another department in the medium, right? Like for example, product management, it's gone, right? I only see HR. Now I can add a column. Suppose that, well, I have a time spent in the company. I have a column that tracks how many years somebody worked in the company. Suppose that I want to track for some visualizations, I want to know how many months somebody spent in a company. How do I add the column? I put the data frame name followed the $, and this is the name of new column. And I assign the values to that column. I take the time spent in the company in this case and multiply by 2. And this is gonna be what? My month spent. Let's run. Now I want to verify what I just did. I'm gonna run the head command to display this for 6 rows. I want to verify that I have months spent as expected. See this? I'm gonna look at my years spent, right? Time spent as a company, this is a 3 years. 3 times 12 is 36. So see that I can preview what actually happened. Sometimes what actually happened is not what happens, is not what you think is gonna happen. Now, how do I delete the column? There is no command, something like a delete. What you do is you set the column to null. And this is one way to delete the column. I no longer need my month spent. I'm going to set it to null. I check and the month spent is gone, right? You have to verify the work. Now, sorting. Oh, wait, first I need to explain to you why you may remove the columns. Well, sometimes the data set may have sensitive data, such as social security number, credit card number, somebody's name. This information should not be used for analysis. Sometimes there could be unique identifier, right? This will slow down some neural network analysis. You want to remove it. Then suppose that there is a column called country and everybody is in US. Does the column add value to analysis? No, right? The same value. So you probably want to remove that. Sometimes the column can have most of the rows could be missing a value in the column. Sometimes you want to remove that column. Well, there are multiple reasons, okay? You will see that later. Now, sorting. Why do we sort data? Sometimes we want to display the top 10, right? Sometimes we want to identify the duplicate, etc. So that's the reason we sort. So how do we sort this by the satisfaction level? Okay, so here, this is a new data frame called HR sorted. What am I doing here? I'm taking all rows sorted by the satisfaction level, and I'm taking all columns. That is what it's gonna do here, right? Here, let's show just first 10 rows, right, and verify. You want to display the first X row, certain number of rows, just because you want to verify that the command did as expected. This one, if you put the minus sign, then it's gonna show it's gonna show the descending. Default is ascending, minus sign is descending. You might be wondering, is it possible to sort by more than one column? Absolutely. So here, this will sort more than one column. First sort is done by satisfaction level, but if you have more people with the same satisfaction, it's gonna look at the number of projects, right? That's what it's gonna do. So that's sorting. Next, we're gonna look at the factor column. So what's a factor column? It's a categorical column, right? Now, let's take a look at what's going on in the data. Employee either left or stayed. You cannot leave half, you cannot leave 1/3, an employee cannot leave 1/3 of the way. You either left or gone. So for some analysis, you want to see if you want to do classification. You want to classify, for example, the employee as left or state, like decision tree or something. Sometimes you want to convert this column to a factor because, well, it stores numbers 0 or 1. But the problem is some methods may start doing the average, like we saw in the summary, right? How could half of the person live? You saw what it was doing, right? It was right now at the moment, if I run the summary command here, right? If I run the summary command on HR left, right? It's wrong because what it's gonna show me is this. Well, Caesars, what does it mean? Mean, medium, how can 1/2 of a person live? See, the value either left or state. So we have to treat as what as a factor. Factor command is gonna convert this to the factor. The values are gonna be 0 and 1, right? So I'm just changing the data type. Now I'm gonna do the summary for the left command, and this is what I want. I want to know how many people left, how many people stayed. That's it. Now here, this is what I want to check. I want to check if something is a factor. Now, since now it's a factor, I can do more analysis on this. I can check, I can print a table. This is a frequency table for a single column. I want to know how many employees getting low salary, how many employees getting high salary, right? How many medium, that's what it's gonna do. But keep in mind that this table can be used as an input for other functions, right? Like here, this is gonna do the proportional table. If I want to see the proportion of people with high salary, low salary, and medium. So I'm gonna run this command now, okay? Absolutely, Alex. After this, I'm gonna give this presentation and I'm gonna give this code to your professor and they're gonna post in the classroom with recording. Yes, you're gonna have all of this, okay? So this is a table. Now, next table command, I have 2 columns in here. What it will gonna do is it's like a crosstab. I want to know how many people with each salary level stayed and how many people with each salary level left. Well, this is what it's gonna do, right? So you have left stayed, right? Stayed left, and you have the salary. So this is what it's gonna do. It's also called cross tabulation, right? Earlier today, I mentioned that some of the columns have missing values. Well, why is it a problem? Because they messed up my analysis, right? Okay, let's take a look at this. I want to calculate on average when was last employee evaluation. So I'm gonna take mean command and I'm gonna run the mean command on evaluation. What? Why am I getting NA? Why it's not returning me the average? Well, the problem is you have some missing values in that column, right? As we saw earlier when we ran the summary, we saw that there are some missing values. What can we do is we can handle them, we will, but in the meantime, you can do this, and ARM equals true. So that specifies to explicitly ignore the missing value. Oh, this is not a trim option, it's an ARM. This is called an ARM equals true. Okay, and ARM equals true, it means that I want to ignore my missing values. So see here the problem is there are some missing values. There is a row where the data is missing in that column, right? So it's not ignoring it, it's failing it. But if I run it like this and ARM equals true, I can calculate it because this will ignore missing values and A.rm equals true. Default value is false. So you have to specify explicitly. You want, if there is a row with a value missing, you want to ignore it for the purpose of calculation, okay? I hope I answered the question, that's what it does. This is explicitly ignore missing values. If value is missing, just skip that row, that's it, right? Now, suppose that I'm looking at the data, I'm not sure if there are any missing values. So this any, well, isn't a, basically isn't a returns if the value is missing. But if I just run this, what this will do, let's see, it's gonna run through all of my rows, all of my columns, and it's going to look at each data value and return true if it's missing and false if it's not, right? But this is too much, right? Too much to start with. I want to know if the data set has at least one missing value in any of the column, anywhere. I'm going to run any command and put here is NA inside. So this is true. Now I know that somewhere, at least once, I have a missing value, at least one row, at least one value. Now, I want to know how many values I'm missing, so I'm just going to take the sum, right? I'm taking the sum, and I know that now I'm missing 2. What is it doing is that, remember, I had true, false. It's going to count how many values are true, how many I'm missing, right? Here, I'm returning if the value is missing. And here, I'm just counting how many, okay? Now, here, I know that one of the columns is last evaluation. Let's see, I want to know, I want to know how many columns, how many values I'm in that column, how many rows in that column are missing the values. So this is what I'm going to do. I'm going to pull. So what this will do, let's highlight just this. This will return, see this will return false, right? So this will just check if the value is missing. But when I do the sum, it's going to tell me the number of what? True, right? It's 1. So I have somewhere, if I scroll, I have a value, one missing value somewhere. I would have to look for it. See here, this is here. This is one row. There is one value where it's true. And if I wanted to know the row number from this, I can say, okay, this is my first element. This is row number 361, 61, 62, 63, 64, etc. And I count. But is this convenient? Probably not, right? This is inconvenient to count. I can do this also. I can run the which command, right? This will return which row number that is missing a value, right? It's 375. Well, I think this is correct because you saw it, right? It was a true. Oh, Jesus, it's in here, right? So we know that this element is 397, 96. You just count and you get it there. This is the element. It tells you the row number that is missing a value. It's in here, 375. Sorry, right? So you know that you can figure it out, right? Here it's very difficult to count. So run the which command. It's gonna give you this. Now I want to display observation that have at least one value missing. Complete command is gonna complete command returns the complete observations. Complete returns rows that have all values, that don't have any missing values. But not complete is going to return the rows and all columns in this case from the data set that missing at least one value. So see this here, I specify the row selection condition, and here are the columns, all columns, because the columns are omitted. And here, not complete. This is what I want. I want to show all rows that are missing a value. Well, see this here, and the missing value shows as an A. See that row 59 is missing average monthly hours, and row 375 is missing last evaluation, right? Here I can show how many, I can take the column sum. I can see how many values each column missing. Sometimes it's very helpful because, well, suppose that I know that I have here near 15,000 observations. And if I know that 14,000 are missing a value, is it worth examining that column? Probably not, right? So sometimes you need to check how many values, how many rows are missing a value. Now, what do we do with missing values? There are multiple options to handle missing values. First of all, we can omit the rows that have a missing value. Well, there is a problem because you may lose data, right? If most of the rows are missing a value, sometimes it's easier to get rid of the column, right? Well, but this is how you do it. In general, NA omit HR, this will create a new data frame without missing rows, right? So remember, we had 2 rows that were missing. How do we check the work? We had 2 rows that were missing, right? In the original data, we have what? This is 14,997 observation. This is a new one, and this is the original. This is HR sorted, but we are using this one. This is HR. This is the number of observations in HR, and the number of observations goes down by 2, right? In the new HR, there are 2 less observations because we know that 2 have a missing value, right? This is how we check the work. And this one, if I just want to create a subset of all missing of all, this is another way to approach this. Instead of saying omit, I can just take a subset, or I can only take the complete rows, right? This is another way to approach it, to do the same thing, to accomplish the same thing. Next thing what we can do is sometimes we can replace the missing values with the mean. But wait a minute, how are we going to take the mean? See, we want to take last evaluation, and we want to replace the missing values with the column average. First of all, we need to take the column average. But remember, the problem is if we take the column average without this option, it's going to return an A. Because I know that I have a missing values, right? So what this does, this piece here is going to return the average, right? Evaluation. Oops. Not sure why I get the negative. Oh, here it is. Now it's correct. I mean, I selected minus sign. That's why. Okay, so here, this is just returning the average, and it's ignoring the missing values. So now what I need to do is I have to take this column, last evaluation. Here, I'm selecting all rows with missing values. So remember this? This thing here will just select the rows with missing. It's just going to select the missing values, right? So I have 1 missing values. And what this will do, I'm going to set in the missing values to this average. This is what I'm doing, right? Okay. Now what I can do, I can also set it to predefined value. For example, if I don't know average monthly hours, I can agree to set them to 200. So that's what it is. So just taking those hours that are not available, right? Average monthly hours that are null and set them to 200. That's another way to handle it, right? Or when I have a categorical something column, and if something is not specified, I can handle it as other, right? I can set it to other. Now let's see, how do I know that my missing values have been handled? I can run the summary command, right? Okay, so scissors and A is gone. And also I can run the summary command on what? On average monthly hours. This meant to be average monthly hours. Okay, so I'm going to run the summary. Okay, scissors and A's are gone. Alternatively, I can check how many values each column is missing, right? Nothing, 0. Okay, now I'll save this to make sure I don't lose this, because here the intent in here was to show the average monthly hours. We did something, we made change. We need to make sure that we did was intended, right? Okay, so here I mentioned to you that everything in R functionality consists of the set of packages. Now, if I want to read more about these packages, this is browse URL, and it will open this URL on packages in my browser. See, you're going to go to your default browser, and you can click on each package, and you can read about it, right? And this is the date of the last package release. And in fact, advanced developers, they write their own packages. We're not going to do that in this course, but just in general. Okay. Well, library command is going to list the packages that you have that you have installed. Okay. Well, this is what you have installed. But remember, installed package is not available until you put it in memory, right? Search command is going to check which packages are loaded or in memory, right? So this one you can use any data sets or anything defined in here. This is available because they are in memory when you load RStudio. This command is going to show the location of the library. There are two types of libraries, the system library, the packages that were pre-installed, and then the user library. This is what you will be installing, right? I can run this command. It's going to show me, well, I have two folders, right? So what is this? This folder is in the program directory, right? These are pre-installed, and this is folder on the Windows PC in the users update. This is my folder, and this user. This is my nickname, Lena. This update local R Windows library, and then there is a separate folder for R4.2. If you use earlier versions, you would need to install all. You may need to install all packages again. If you use 4.1, if you use R.1, if you use R4, sometimes you may have to install packages again. Because CSS, it's a separate folder. That's what it's doing, right? Okay, so the next thing is install packages and package name in a double quotes. This will install the package, right? I already have it installed, but it's gonna just, yeah. Okay, one thing is here is that this is a warning, right? So not all, if the message is in red, it does not mean that it's an error, okay? Some messages are informative, all right? So here it says the package successfully unpacked, it's installed, but I cannot use any functions from it because it's not available. How do I know? If I go to packages here, do you see that there is no check mark in here? The package is not available until you actually put it in memory. What do I have to do is I have to run, either I can run library command or I can run the require command. Now take a look at this. This is not an error. This is informative message. It tells me that something in my arrows package depends on the matrix package. So it has to load matrix package into memory also for them to be able to load a rule package, right? Here it just showing, it's just telling you that you have another package called base that has methods with the same name as the rules package. That's what it does, okay? This message is informative, okay? And if you scroll down all the way to matrix, you should see there should be a check mark if you find it. But well, it has to load the required package matrix. Well, see this, it's sorted, but the problem is sorting is case sensitive, right? So, but if you look through it, or if you do this, if you run the search command right now, you're gonna see that a rules package was loaded into memory and matrix is in memory. See this? Okay. Now, well, what else you can do is you can also run require command to load package in memory. Now, suppose that I want to read about the rules package. I can run my help command. So I can put library and then I put help and the package name. This will just give me information on this package, right? This is just about this package, okay? Like who wrote it and etc. Next thing is, well, some packages have a VNet. It's a PDF file and it's part of the package installation, so I can do that. And this will open the VNet in a browser. This file was installed together with the package installation, okay? I can browse VNet online, or here, this command, once in a while you want to get the latest package versions. So this command will update all user packages that are not up to date, okay? Sometimes you want to unload the package. Unloading the package means removing the package from the memory, okay? But detach command, right? This is unload. It will remove package from the memory. It's not gonna delete the package. It's not gonna uninstall. It's just gonna unload from the memory. Remove command is gonna uninstall. Okay, remember that. Now, part of the analysis that you're gonna do is the data visualization. There are different visualizations that you can use. For example, if your column is numeric, you want to use a histogram, right? You're going to show up as frequency bars. Here is my histogram. HIST is going to run the histogram. But the problem is, take a look at this. Do you like the labels? No, right? I believe there is a question on a test, not on the test, sorry, quiz, where you ask to, how would you show the title, right? So you may want to have your exercises in front of you, and you may want to have R open. If you get that question about the title, what you can do is you can run this question mark, right? You can run the command to see, right, information on the histogram command, and you're going to see what each of these input parameters does, and you can figure out which parameter you use to specify the chart title. Okay. Well, but see here, I'm just showing you other stuff that you can do. You can change the number of breaks, you can change the border, you can change the colors. You may use multiple parameters at the same time, right? So basically, as you practice or as you do your own analysis, don't limit yourself to the minimum. Try to see what's there, right? Okay, bar plot. Bar plot takes the frequency table as an input. There are two ways to do it. You can create a frequency table, like here I can create a salary table, right? So this is my salary table, and then I can pass it into the bar plot command. I can do that, see this? So this is a bar plot. Now, I'm not going to limit myself to this. What I could do is I can order the bars by the height ascending. See this? So what I do is I say order, and I'm order this salary table. I'm going to sort this, right? So see this thing here. If I just take this, if I just run this sorts the table, right? Ascending, this sorts it. Now I can also sort my visualization. I can order this bar ascending, right? Then I can also show it horizontal, right? And then I can also do both. Can I sort it and show it horizontal? Of course, right? I can do that. Oops, not sure why it did not do it. But anyway, just know it's possible. I'll have to look at this. Okay, you can do both sorted and you can do both horizontal. Okay, now this is a pie chart. Well, but are you limited to this? Well, no, right? If you want to know how to change colors, you're just going to look at the help of the pie chart command. Pie chart command has a little problem. If I have multiple values, so here, see this is just 3. But see, the purpose of the bar plot is to show the proportion, right? Portion of the rows that have a specific value. But the problem is, what if I have 100 different values? Is this going to be readable? No. So you may use the bar plot instead, depending on how many values you have, right? This is for numeric values. You can use the box plot, right? This is for numeric ones. Then you can use the generic plot function, but generic plot function will try to pick up what you want to do based on the data type. So in this case, it's just doing like a histogram or bar plot, sorry, bar plot, right? Because it picked up that the column is categorical. Alternatively, see this, I can do this. I take the salary and I picked up the values, but I want to show the line. I want to do type line, right? So this is a line. Instead of just showing those bars, I want to put a line, no problem. 2 categorical columns, I can do that too. Or I can plot the average monthly hours. It's not gonna look nice, trust me. It's not gonna look nice, but you just know that you can plot 2 columns against each other, and you can plot the monthly hours. Well, you probably want to look at the subset in this case. Well, you just know it's possible to do, that's all. Now we're gonna go back. I know that I was not going to the slides. I went straight with the code, but I spelled everything out here, okay? It's just an explanation of what we did. As I was preparing, I was taking notes, and I'll let you have a copy of those notes, basically. Think of it this way, right? Well, see, this is an example of adding a column, and I'm explaining to you why you would sometimes delete the column, right? You may have unused columns. You want to reduce the storage. It's another reason, right? Or you don't have values, or you may have skewed column. Everybody is from US. Who cares about country column, right? It's just taking up the space. Well, things like that. Right? So you got the descriptive statistics. I explained what this is here, right? The sorting, we talked about it. Then I showed you how to do the frequency count. You're gonna have the slides. And this is more like on missing values. It's an explanation, right? I showed you how to install the packages. You're gonna do a rules package is gonna be your first package. You're gonna use it for the in the cars exercise. Then you're gonna use it in a association rules, which will come for the week 3. You're gonna run association rules method, and it's gonna be in a rules package. Okay, so that's your first package that you'll use. Okay, well, this is just some useful commands. Like library, you want to see user installed packages. Search is what is loaded in the memory, right? Well, in etc. We talked about that command. Those are just spelled out when would you use each visualizations, because sometimes you're not sure which one to use, right? But be careful with the pie chart, because if you have too many, it's gonna be cluttered, right? It's not a good idea when you have too many values. But if it's just 3, perfect, right? And if you have time, you can explore how to show percentages and etc. There are so many things you could do, right? And there are different packages that can do the visualizations. I just selected basic because, otherwise we will be here until morning. Oh, this is just generic plotting. I just have this for you explain when you do. And another thing, very important. There are 2 files in here. Our history, that's a file that says the history. Our data, that's a file where our workspace is saved. So sometimes if you save the whole workspace, when you start the next R session, your save environment will be preloaded, right? So this is what our data does. You can save your session, right? So those files are called 2 hidden files, our history and our data. But in general, to quit, you're just going to run the Q command, right? The command is in here. You run the Q command to quit the RStudio session, right? Another thing that I forgot to tell you is that there is no explicit undo. Suppose that I deleted the column from my data frame by accident. There is no way to undo it. But wait a minute, there is a way to undo it. What I can do is I can reproduce work by rerunning the code, can't I? Well, see, like if I go back in here, I deleted the monthly hours, right? I deleted something. I did something silly that I didn't really want to do. And that caused me to lose some columns. Yeah, there is no undo button. What am I gonna do? I lost it. Well, don't panic, because you listened to Elena and you saved all your work into what? Into the file, into our code. So what you would do, you messed up the data frame, no problem. You're gonna go back here and you're gonna read your data again, right? And you're gonna rerun the code. Very easy. 1 or 2 minutes and you have it back to where it was. But on the other hand, if I did not have this nice file, it's gonna be hard. You would have to redo the whole assignment again, right? No way. So you're gonna remember it. You want to save the code. And every time when you deleted something by accident, you can just rerun the code and rebuild it. Not a problem. You're not going to be staying all night. You just run this. Very easy, right? Easy secret. Okay. Now, the thing is, those are very helpful LinkedIn group. I'm a member of both. So if you're really interested more in R after this class, you can join LinkedIn groups and, see what people discuss. Those are just some additional references. I have to specify the references in my presentation, so I throw some in there. Okay. Now, that's time for questions. Anybody has questions? And if you remember me from earlier course, I like when students ask questions. That's your opportunity. That's a customer service. Your chance tonight to ask questions. Well, I know that you may need to watch this recording more than once. right? Any questions about anything? Well, while you're thinking about questions, I can tell you one thing. Some questions on a quiz have multiple answers. If you need to select two answers, it says in the question to select two answers. Just remember that. If it says to select two answers, you want to select two answers. If you select only one, you're gonna get question wrong, okay? So how to upload the CSV file in R? Okay, let's take a look at this again. I have a folder, right? Somewhere on my C drive, I have a folder that I call the data sets. Well, this is a folder, and this is my data set, right? I save R files in here. What you have to do is, first of all, you want to make sure that you are reading the file from correct directory. You have to set the working directory, set WD data sets, right? So that will do that, because the file that I want to upload is sitting in that directory. Now I'm going to use read CSV command in order to upload the file into HR data frame, right? I'm going to do that, but first let's do this. Let's do. I'm going to delete everything. I want to delete everything. Okay, just to say. So this is a folder where I'm going to read. I'm going to look for the file. This is the data frame. This is assignment operator. I'm going to use read.csv command. That's what I'm doing here. Read.csv command is going to read the CSV file into the data frame called HR. Now, why am I doing this? Because in my file, if I go to my file, it's in here, and if I open this file, you can see that the first row is column names, right? If I don't tell R to use my column names, it's just going to name the column. It's just going to treat it as data. So I have to say that I have to specify that this first row, what you see are in fact the column names. I don't want this to be treated as a data row, right? That's what it does. Because otherwise it's going to treat it as a data row. It might treat it as a data row and name it column 1, column 2. You don't want it to do this. Just to make sure that it does not do this, you want to be proactive. You just specify this header equals true. Separator, well, you specify that it's comma delimited, right? So sometimes the file can be column delimited or pipe delimited, right? S is equal false. Well, because you want to make sure that the columns are not read as strings, because then you won't be able to do the analysis on the categorical columns. Now, here is just previewing the data. This is analysis, but please let me know if I answered the question. So first step, make sure that you save the file. You know where the file is saved. You need to set that working directory, right, to the folder where the file is set. Next is you run the read CSV command. You must specify the correct file name. It's case sensitive. You have to specify that the first line in the file contains column headings. You specify the separator, and then is false. Basically, what you will do is you're gonna take this line of code, you're gonna change the file name, and you're gonna change the data frame name. You want to make sure that the file actually saved, right? And maybe you have a different drive, maybe you have a different folder. It's up to you, right? Sometimes you create a separate folder per course in your hard drive, right? Things like that, but I have a folder called data sets, and I put all data sets that I use for the demo. I use one here in this case, okay? Let me see the chat. Alex, please let me know if I answered the question. Okay. Yes, okay, excellent. So that's how you're gonna read the cars data file. There is a cars file for exercise 2. And I need to clarify that you need to do those exercises because well, you need to learn the topic. It helps you practice. And secretly, when you take that quiz, at least for the first quiz, there are some questions on exercise output. So you may want to have it like around you as you take it. There are 40 questions in the question bank, but this will randomly select 20 from the pool of 40, you have 3 attempts. Do you have to take all 3 attempts? No. If you get 100% on the first attempt, you're good. But if you take all 3, first of all, you're going to see more questions, right? Because when you retake it, you may see different questions. Then the attempt that goes to your, the grade that goes to your gradebook is the highest grade, so there is no harm. For example, if you got 90 on the first attempt, 95 on the second, right? 95 goes to the gradebook. Or if you get 95 on the first attempt, 70 on the second, still 95 goes to the gradebook. So basically, there is no harm of taking it again. It just helps you see different questions, maybe, and it's just for you, it's a review. Then when the time comes for an assignment, you are prepared. All right. So no time limit. You may use anything you want, right? Of course, not your classmate, but you know. And the answer choices are in random order. So you're not gonna say, hey, you're not gonna tell your classmate that the answer is A to question 1, because your friend might get a different question 1, and the answer choice might not be A. You know what I'm saying? Answer choices are random, so that way you're not gonna be sharing. You can share, right? How you're gonna share? See? And another thing is that if the question is answered correctly, it's gonna tell you that. But if the answer is wrong, it's not gonna tell you that the right answer, but it's gonna tell you that your answer is wrong. Okay? So if you know which answer is wrong, it's easier to know which one is correct. So basically, that's how it is, and you have access to past attempts. So just it's a matter of a test taking, right? So if it says to select 3 answers and you select only 1, you know, things happen. Okay? So you want to do 2 exercises and do the quiz, do it. You get 3 attempts, but you want to do it at least twice. Well, if you get 100 on the first attempt again, you know, you're happy with the grade. Okay. You want to see other questions too. It's up to you. Okay? But you're not gonna be penalized for taking it only once. It just that's what you got, what your grade, you know. Just explanation on how that works. In case, you know. Okay, so anything else? Well, I like questions because some people might have the same questions. And yes, you will get this slides, you will get this after this. When the recording is processed, I'm gonna immediately send an email to your faculty and they will share it with you. Okay, so one new message. Oh, most welcome, Alex. And I would like to thank to everyone for attention because it's an opportunity to ask questions and then you can watch it again and you will remember what was covered and you will remember maybe in which order things are covered, things like that. So you may need to watch part of this again. That's normal, that's fine. Okay? So are there any other questions from anyone else? No? Well, if there are no questions, then we're gonna call it a night, and I wish you all successful data 630 class. Okay? I will stop the recording and stop sharing, and you're gonna get all of the files after this. Okay? So stop recording.